Example 3. Plot the graph of f of x is equal to the square root of x on the grid below using what you learned in section 3.4. For each remaining function, construct a table of x,y values. Tables are provided on page 6 and use the points found to sketch the graph of the function. Graph all functions on the grid given below using a different color for each function. And the functions here are, in example A, f of x is equal to the square root of x. In part B, g of x is equal to the negative square root of x. In part C, h of x is equal to the square root of negative x. And finally, in part D, j of x is equal to the negative square root of negative x. All right, so this is very similar to what we did in example 1. We are going to be taking one of the basic functions that we learned in section 3.4 and we're going to graph it, and then we're going to make a table of values for other functions that involve that basic function, and we're going to plot all of these graphs on the same grid to discover more transformation rules. Okay, so in example 1, we discovered basically the rules for horizontal shifts and for vertical shifts. And so now in doing this exercise in example 3, we are going to develop another set of transformation rules. Okay, so let's start with the basic function here. That is that's part A here. F of x is equal to the square root of x. We learned what the square root function looked like in section 3.4. Okay, so remember I told you you had to memorize the key points to each of those graphs. For the square root of x, it starts at the origin. Okay, so it'll go through the origin, and then also on this graph is going to be the point 1, 1, and then 4, 2, and then lastly 9, 3. Okay, and so if we connect these dots, again, it starts at the origin. Okay, this is what f of x is equal to the square root of x. That's what that function looks like. Okay, if you examine the equations in parts B, C, and D, they all involve some variation of the square root of x. Okay, what you actually see is, in addition to the square root of x, you see some negative signs. Okay, so sometimes the negative sign is outside of the square root, sometimes it's on the inside, and in part D, it's in both places, on the inside and on the outside. Okay, so we are going to move over to page 6, okay, and we're going to make a table of values for those 3 other functions. And once we have our table of values, we will come back and plot each of those graphs just to see how they compare to the original basic function. Okay, I am going to color code these as well, like I did in example 1, so we can tell which graph is which very easily. Okay, all right, let's get started here. I am first going to make a table of values for g of x is equal to the negative square root of x. Okay, so if you flip back, that's the equation in part B. Okay, so let's go back to the table here. Okay, we are always in charge of x. We get to pick the x values. We plug them in and get a corresponding y value, and then that gives us an ordered pair x, y to plot. Okay, I am going to stick with the x values I used in example 1. So if you remember, I used like -3, -2, -1, 0, 1, 2, and 3. Okay, so let's try these guys out. Okay, so you're going to go to the equation, and wherever you see an x, you're going to replace it with the x value that you've chosen. Okay, so keep in mind here, the function is negative square root of x. X is underneath the square root. Okay, all right, so if x is -3 here, okay, we're going to get that the y value is, there's a negative on the outside. That's going to be this negative that's hanging out front. Okay, then we're going to have the square root, and then we're going to plug in x. Well, x is -3 here. Okay, so as soon as you do this, you realize this is a problem. okay, you end up with a square root on the inside. Okay, so you have a you end up with a negative number underneath the square root. You can't take the square root of a negative number. Okay, so this is an error. Okay, you may be wondering, well, what about that negative sign in front of the square root? Okay, it's okay to have one outside of the square root. You just can't have one underneath. So what's going to happen here is you cannot plug in negative x values, okay? Because if you plug in a negative x value, you're going to end up with a negative under the square root, and you can't do that, okay? So we need to rethink our x values that we're using, okay? Along the same lines, okay? If we turn our attention to positive x values, think about what happens if you plug in x equals 2. If you have that, you're going to get that the y value is equal to, you've got that negative sign hanging out front, so it's still going to be there, and then you're going to have the square root of 2. Okay, so you would plug in positive 2 for x. The thing about this is you don't get an error message. It's perfectly fine to take the square root of positive 2, but it is a crazy decimal number, and we don't know it off the top of our head. Okay, so what we're learning from just kind of playing around with x values here, we can't plug in negative x values. Okay, we're going to have to plug in x values that are positive, because you can take the square root of a positive number. You can take the square root of 0, so we can plug in 0. Okay, but we have to be smart about which positive numbers we pick. We want to choose x values that we know the square root of. Okay, so think back to the basic function. What worked for the basic function? For basically f of x is equal to the square root of x. Well, our key x values were 0, 1, 4, and 9. Why? Because we know the square roots of these things, and they're positive. Okay, all right, so we're going to plug in these x values, and that's what we're going to make our table from. Okay, so remember, this negative sign is going to hang out front each time. Okay, so if x is 0, we're going to get that the y value is equal to negative, that's the guy hanging out front, negative square root of 0. Okay, that's going to be the negative sign hanging out front. The square root of 0 is 0. Okay, so negative 0 is just 0. Okay, so the point that we're going to plot is 0, 0. Okay, moving on to x equals 1. Here we go. Y is going to be equal to the negative. That's the yellow negative sign hanging out front. Square root of x. X is positive 1. Okay, so this is going to be negative. Square root of 1 is 1. Okay, so the point you're going to plot here, if x is 1, y is negative 1. If x is 4, plug it in. Okay, y is going to be, you've got your negative sign hanging out front. Okay, and then we're going to have the square root of x. X is 4 here. Okay, so this is going to be negative out front. Square root of 4 is 2. Okay, so we will plot the point 4, negative 2. And then lastly, we'll do one more. If x is 9, we'll get that y is equal to negative hanging out front. Square root of 9. Okay, so this is going to be negative hanging out front. The square root of 9 is 3. We will plot the point 9, negative 3. Okay, I am going to go ahead and plot this graph out. Okay, so let's go back to this page. We are going to have, basically, I'm putting this graph in blue. It's also going to go through the origin. Okay, and then our other points are going to be 1, negative 1. So 1, negative 1, that's right here. And then we've got 4, negative 2. That's right here. And then lastly, the last point is 9, negative 3. Okay, so we're going to connect these dots with the same basic shape as the original function. Okay, we're going to start at the origin, and the graph is going to go this way. Okay, so this is the graph of g of x is equal to negative square root of x. Okay, all right, let's go ahead and talk about what happened here, basically how the black graph got moved around. If you notice, this is a reflection. The blue graph is a reflection of the black graph. about the x-axis, okay? Meaning, if this were a sheet of paper that you could actually fold, if you took your sheet of paper and you folded it along the x-axis, which is this yellow line, okay, the black graph would fall directly on top of the blue graph. Okay, so that is what's happened here. Okay, this is very much tied to symmetry. Okay, if you think back to the symmetry rule for x-axis symmetry, for x-axis symmetry, if you start with a point xy, okay, for x-axis symmetry, remember x would stay put and y would change signs. Okay, that's what's going on here. That's another way you can see that this is x-axis symmetry. Okay, so basically if you look at the points here, the origin did not change. Okay, but on the original graph we had the point 1 1. Okay, and then on the transformed graph the x value stayed put and the y value changed sign. Okay, and you can see that with the other 2 points. On the black graph, the original point is 4 2, and then if you fold the sheet of paper along the x-axis, it goes to 4 -2. The x value has stayed the same, the y value has changed sign. Okay, same thing with 9 3 on the original graph. Okay, if you fold the sheet of paper on the yellow line along the x-axis, that point gets sent to 9 -3. Okay, x value stays put, y value changes sign. Okay, so that is what has happened here. Okay, the blue graph, okay, this is a reflection of the original function, square root of x, about the x-axis. Okay, now how do the equations compare? Okay, so if I compare the original function to the second function, the one that we graphed in blue, okay, both have the square root of x, okay, but for the blue graph, there's a negative sign in front, okay, so that's going to be your transformation rule. Okay, let's jump to page 7 and write this down. Okay, it says, note that the graph of g of x is equal to negative square root of x is the graph of the original function. F of x is equal to the square root of x. All we've done to get the blue graph from the black graph, the black graph has been reflected about the x-axis. Okay, all right, so at the bottom here, okay, I'm kind of jumping around here, but here's the transformation rule. Okay, if you start with an original function, f of x, and all you do to it is put a negative sign out front, okay, that is going to cause you to reflect the original graph about the x-axis. Okay, all right, so basically you can see this new set of transformation rules that we're learning, they are reflections. Okay, they involve the original function and negative signs. If the negative sign is out front, the reflection is about the x-axis. Okay, let's go back to page 5. Let's look at part C here. We've got a brand new function here. This time, the negative sign is on the inside of the square root, which may raise alarm bells to you. H of x is equal to the square root of negative x. Okay, so let's go to page 6. Okay, we're going to go to the table of values to the right here, okay, and we're going to try to make a table of values. Okay, so if I use the same x values, okay, things that I know the square root of, so I just use 0, 1, 4, and 9 for the first, or for part B. If I use these same x values, okay, look where the negative sign is. Now it's on the inside. Okay, so let's see what happens. So if x is 0, we're going to get that y is equal to the square root of negative 0. Okay, order of operations says you need to simplify what's underneath the square root first. So the square, or negative 0 is 0, so you'd be taking the square root of 0, that's just 0. So this graph is also going to go through the origin. Okay, all right, then we move on to x equals 1. Okay, and I actually forgot, I meant to put all of this in a different color. Okay, so hold on, I will change the rest of these guys after. I'll do this one in green. Okay, so if x is 1, y is going to be, okay, square root of negative, okay, so that negative is underneath, okay, negative 1, okay, so, okay, the negative is underneath, and then you write down the x value, okay, so we've got the negative underneath, and we write down the x value, so you end up with the square root of negative 1, which is bad, 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 because you end up with you're taking the square root of a negative number, okay? Same thing's going to happen if you plug in positive 4, okay? You would have the square root, you'd have the negative already underneath, and then you write down your x value, and you're taking the square root of negative 4. It doesn't work. You can't take the square root of a negative number. So at this point, you may be like, well, you just can't do this, okay? Well, you kind of have to get smart here. This function exists. You can do this, okay? You have to be smart about it. There is a negative sign already underneath the square root, okay? If instead of positive values, if we instead plugged in negative numbers, okay, you would already have the negative that's there. And then when you plugged in your negative number, like negative 1, you would have negative times negative, and that would turn positive, and you would have something positive under the square root. So this is totally doable, okay? You just have to change the types of x values that you plug in, okay? Because there is a negative sign underneath the square root, you have to plug in a negative x value so that the negative times the negative turns it positive, okay? So we are going to change things up here. Okay, we're going to go ahead and plug in negative x values instead of positive ones. 0 is okay. Okay, you can see 0 worked out fine. Okay, so for this particular function, the x values you can plug in are 0 or things that are negative. Okay, all right. So let's go ahead and do it. If x is negative 1, then your y value is going to be the square root of the negative sign is already underneath, and now we're doing negative x. So we've got the negative, now we write down x is negative 1, okay? So under the square root, negative times negative is positive, you get positive 1, which is 1. So you're going to end up plotting the point if x is negative 1, y is positive 1, okay? All right, let's try x is negative 4. Okay, in this case, we're going to get that the y value is the square root of, we're going to have the negative sign that's already underneath, okay, and then we're going to have negative x. We write down x is negative 4. Under the square root, we've got negative times negative, that turns it positive. Square root of 4 is 2. So we're going to plot the point negative 4, 2. And then we'll do x equals negative 9, same thing. Y is going to be the square root of negative. We're already going to have the negative sign there. And then we do negative x. X is negative 9. Okay. Under the square root, we've got negative times negative. That's going to be positive 9, which is 3. And so our last point to plot here is going to be negative 9, positive 3. Okay. So let's go back to our grid and plot this particular graph in green. Okay, so my grid is over here on page 5. Okay, this graph also goes through the origin. Okay, so then if we look at our other points, we've got negative 1, positive 1. So let me go ahead and erase this right here. And so, hold on, let me redraw what I had. All right, so we're going to have negative 1, positive 1. And then we are going to have negative 4, positive 2. And then our last point is going to be negative 9, 3. Okay. Now, the graph is going to have the same basic shape as the black graph. It's just been moved. Okay, so it's going to start at the origin. Okay, and it's going to go this way. Forever. Okay, so this one is h of x is equal to the square root of negative x. Okay, so very same shape as the black graph. It's just been flipped. Okay, what has happened here? Okay, so we've got to figure out, how does this black graph essentially get transformed? Okay, well, what's going on here, this is a reflection about the y-axis. Okay, so this particular one is going to be a reflection of the original function about the y-axis. Okay, again, if you were imagining that this was an actual sheet of paper, okay, and we folded the sheet of paper along the y-axis, which is this blue line that I'm highlighting, okay, then the black graph would lie directly on top of the green graph. Okay, in terms of symmetry, when we studied that, we said for y-axis symmetry, if you started with a generic point x, y, for y-axis symmetry, y stays put and the x coordinate changes sign. Okay, and that's what's going on here. Okay, both of the graphs, green and black, go through the origin, but if you look at the point 1, 1 on the black graph, where did it end up? Well, if you folded your sheet of paper along the y-axis, it would end up right here at -1, +1. Okay, notice both -1, 1 and 1, 1 have the same y coordinate, but the x coordinate changed sign. Okay, same thing. 4, 2 is going to get shipped to -4, 2. Okay, the y value stays +2, but the x coordinate changes from +4 to -4. Okay, same thing with the last point. Okay, originally you had 9, 3. It gets shipped to -9, 3. The y coordinate stays 3, but the x value changed from changed from +9 to -3. Okay, so this is a reflection about the y-axis. Okay, so if we go to page 7 at the top, okay, we can jot this observation down. In this middle bullet point here, we are comparing the graph of the original function, which is f of x is equal to the square root of x, to h of x is equal to the square root of -x. So now the negative is inside the square root. Okay, so basically, if you take your basic function and you put the negative on the inside instead of the outside, that is going to cause a reflection. Let's see here. Let me put reflected about the y-axis. Okay, and if you come down here, okay, here's the rule. Okay, if f of x is your original basic function, okay, and you put the negative on the inside, okay, so remember, we were just working with the square root function. I told you to think of that like parentheses because it traps your content. So if the negative is inside parentheses or if it's inside the square root, that's going to cause a reflection over the y-axis. Okay. All right, going back to page 5, we have one more grid to do, and I will put this one in red. So for part D, j of x is equal to the negative square root of -x. So this time you've got a negative sign on the outside and also one on the inside. Okay, so you can probably guess what's going to happen here. Okay, remember the negative on the outside is to reflect about the x-axis. The negative on the inside is to reflect about the y-axis. If you reflect about the x-axis and you reflect about the y-axis, you're essentially reflecting about the origin. Okay, so you're going to find out, we're going to make a table of values for this one. We are doing a reflection of the black graph, which is the square root of x, over the origin. Okay. All right, so let's try this. We are going to jump to page 6. There is another table of values at the bottom here. Okay, we have a negative on the outside of the square root as well as one on the inside. We learned when we built the last table of values, since we have a negative under the square root sign, we need to pick 0 and negative values for x. Okay, so we're going to pick 0, -1, -4, and -9. Okay, we have to remember there is a negative sign that is on the outside and there's one on the inside to keep track of. Okay, so if x is 0, we're going to get that the y value is going to be the negative sign that is out front, then the square root of the negative sign on the inside, which is the blue one, and then you write down x. x is 0. Okay, so this is going to be the negative square root of negative 0 is 0. And so then we're going to get negative on the outside. The square root of 0 is 0. Negative 0 is 0. Okay, so this graph, all four of these guys are going through the origin. All right, let's take a look at what happens if x is negative 1. Okay, if x is negative 1, the y value is going to be, we're going to write down the negative on the outside, the square root, the negative on the inside, and then we're going to write down our x value, which is negative 1. Okay, so we're going to have the negative on the outside underneath the square root. Negative times negative will be positive 1. Okay, so then to simplify, you'll have the negative on the outside. The square root of 1 is 1. Okay, so this whole thing simplifies to be negative 1. Okay, so we're going to plot the point negative 1, negative 1. Okay. All right, moving on to x equals negative 4. Okay, we're going to get that the y value is, we've got the negative on the outside, then we write down the square root, then we've got the negative on the inside, and then we write down x, which is negative 4. Okay, so to simplify, we will keep the yellow negative sign on the outside, then we will write the square root. Underneath, negative times negative is going to be positive 4. Okay, so then you've got your negative sign that stays out front, and you're multiplying that by the square root of 4, which is 2. Okay, so the whole thing will become negative 2. You're going to plot negative 4, negative 2. All right, one more. Okay, so if x is negative 9, okay, y is going to be the negative out front in yellow. Write down the square root. And then we have the negative sign on the inside, which I'm shading in blue. And then you have to write down x, which is negative 9. To simplify, you have the negative on the outside in yellow. The square root of underneath the square root, negative times negative is positive 9. So you'll have the negative out front times the square root of 9, which is 3. So this is going to be negative 9, negative 3. Okay, these are the points we need to plot to get the last graph. Okay, so going back to the grid, we're going to plot 0, 0, negative 1, negative 1, and then negative 4, negative 2. And then lastly, we have negative 9, negative 3. That is over here. Okay, the graph will start at the origin. It will have the same basic shape as the square root function. Okay, so here we go. Okay, this is j of x is equal to the negative square root of negative x. Okay, so origin symmetry is probably the one that is visually most difficult to see. Okay, if you imagine taking the black graph and doing both flips, if you first flip it over the x-axis, it will become the blue graph, and then if you flip the blue graph over the y-axis, it will turn into the red graph. Okay, so this is definitely origin symmetry. The other way you can visualize this if you struggle with it, remember when we learned symmetry, we said if a graph has origin symmetry, if you take a point x, y to start with, then you change the sign of both coordinates. Okay, so if you're comparing the black graph to the red graph, okay, they both go through the origin. If you take the point 1, 1 and you change the sign of x and you change the sign of y, that sends you to negative 1, negative 1, which is this point. Okay, if you take 4, 2 and you change both signs, the point's going to get shipped to negative 4, negative 2. The last point here, if you take 9, 3 and you change the sign of both coordinates, you're going to get negative 9, negative 3. Okay, you're changing the sign of both x and y. That is origin symmetry. Okay, so to summarize this at the top of page 7, okay, this bullet point right here for j of x, how does that compare to the graph of f of x? Okay, remember f of x is the original function. It's the square root of x. That's the black graph. We are now comparing that to the red graph, which has the equation j of x is equal to the negative square root of negative x. So it's the same basic function, but now you've got a negative on the outside and on the inside. So if you put both negatives, one on the outside and one on the inside, that's going to cause the original function to be reflected about the origin. Okay, and if you scroll down here, okay, it's summarized in the box. Again, the original function is f of x. Okay, if we put a negative sign on the outside and we put one inside the parentheses or inside the square root or inside the absolute value, so one on the outside, one on the inside, that is going to cause a reflection about the origin.